here's how we're going to go about proving that it's impossible to determine whether a function contains an infinite loop or not. We're going to say, okay, let's say you could do that. That means that you could write a function called halt. So we'll call it halt like that. And it'll take a function, and you can think of it as a string rather than as a Python function, a string that contains a function. So something like that. So something like def-g, and then you define the function, and then you close the string. And it'll take x. This will return true if f does halt, so halts on input x. So in other words, it means that if you call f of x, there will not be an infinite loop if you're returning true. Otherwise, you'll return false. So if halt fx is true, then f does not produce an infinite loop on input x. On the other hand, if it's false, then there is an infinite loop there. Now, the claim is you cannot do this. There is no such function halt. But let's proceed as if there were. Now, if there is such a function, well, let's try and come up with an example where we can show that the existence of this function just makes no sense. So here's what we'll do. We'll construct a function that's called confused. And that's just a name, of course. And it'll take a function f as an argument. We won't say what it does, we'll just kind of write it out. So we'll say if halt f, so that means that you would be feeding the text of f to f itself. You're allowed to do that. This could be x could be a function as well. So if that is true, then we'll produce an infinite loop. So we'll say while true, pass. Else, we'll return. Let's say false, doesn't matter what. So this is the function. We are allowed to do that. We are allowed to say, well, we define the function. Of course, we assumed that halt exists. If halt doesn't exist, then we can't really define confused. So let's go one step further, and let's try to figure out what is confused of confused. So let's go through the possibilities. Well, either it produces an infinite loop or it doesn't. Let's say that there is no infinite loop. That's one possibility, so let's just assume it for now and go with it. So let's say that this does not produce an infinite loop. Well, if this does not produce an infinite loop, let's try to trace it. So you say confused of confused. So now we call it, so f is confused, and now we say if halt confused confused do an infinite loop. So what this means is that if this produces no infinite loop, then it produces an infinite loop. Makes no sense. So that means that if you assume that this produces no infinite loop, you can deduce that you get to here and it does produce an infinite loop, which means that this wasn't a possibility in the first place. This is not happening. What about if it does produce an infinite loop? Well, if this does produce an infinite loop, that means that halt ff is actually false, so you jump here, because f is equal to confused when you call confused of confused. So that means if it produces an infinite loop, you can deduce that there is no infinite loop. So that means that, well, this assumption was obviously wrong, because from this assumption you could derive this. This makes no sense, so this is not a possibility. This is not a possibility either, for the same reason. If you say that that this produces an infinite loop, you can trace it and figure out that, oh, it doesn't produce an infinite loop after all, so this is also not a possibility. So what we can deduce from that is that confused of confused, it neither produces an infinite loop, nor does it not produce an infinite loop. So that makes no sense, that cannot be, that's nonsense. How can it be that we got to this point? Well, the problem was that we assumed that halt actually exists. It does not. Because halt does not actually exist, assuming that it exists leads to all sorts of absurd conclusions, like that confused of confused both produces an infinite loop and does not. So the upshot is, well, we assumed that this exists and we derived a contradiction. That means that this function just doesn't exist. This is not a trick, it really does not exist. What are the implications of this? Well, obviously, the first thing you could say is, well, in general, you cannot write software that will take Python code and determine whether it produces an infinite loop or not. We just proved that it's impossible. That's interesting, because that means that there is a limitation on actually physical devices that you can make. So you cannot make a physical device that works like this. That's kind of amazing. How is it that TAs in CSC180 manage to figure out whether your code, the student's code in CSC180, contains infinite loops and therefore it needs to have marks deducted or not? Well, the answer is that in general, TAs cannot do this either, probably. In fact, most TAs could probably not prove Fermat's last theorem by themselves. They might have heard about it, they probably cannot prove it. That means that for the example that we had on this whiteboard a couple minutes ago, they could not really determine whether that was an infinite loop or not. It's a hard problem. For more on the implications of this, see the next video and the linked articles.